Here we go. It's good to see you again as we go into using logarithm rules to make differentiation easier, essentially. So basically, just always remember this rule. Always look to see if I can use log properties before I differentiate, right? That's very, very important. What am I talking about? Well, you could differentiate this as usual. 1 over stuff, d that stuff, ooh. No, 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 that's going to involve the chain rule. No thanks. We can avoid it though. So if you can rewrite a logarithm using log rules, do it. That's why we went over the log rules in the first video in chapter 5. So this can be rewritten as ln of x squared minus 1 to the 1/3. Then using our log rules, we can take this exponent, since it's the ln of stuff to the 1/3, and swing that thing right out front. So keep in mind, we've yet to take a derivative. That's very important. A lot of people will be like, oh, I'm done. You haven't actually derived yet. You've used pre-calculus, stuff before calculus, to arrive at something that will be nicer to differentiate. Now, notice here that when we take the derivative of this thing, we now no longer need to deal with the chain rule with the 1/3. Still going to be a chain rule, but it's not going to be as gnarly. Okay, so the derivative, f prime of x, is equal to, that 1/3 is just chilling, times. Now we've got 1 over stuff, so it's going to be 1 over x squared minus uno times the derivative of stuff. So 1 over stuff, d stuff, just like we saw in the previous video. Got the 1/3. You know you're done because you've taken the derivative of the innermost function. That's it, the derivative of stuff. So let's simplify this out. I'll have 2x in the numerator, 2x times those two 1s, all over 3 times all of this. Now I'm going to leave it as 3 times x squared minus 1. If your teacher wants you to distribute it, you could have written it as 3x squared minus 3. It's fine that way. Okay, how about that problem? This one right here. This one's even nastier, right? Can you imagine taking the derivative of this, 1 over all of that, it's gross enough to copy, times the derivative of all of that? Are you kidding me? No thank you. So we're going to use our log rules again to rewrite it. So again, this is not the derivative yet, we're just rewriting it. So we have the ln of this times that divided by that. So ln of x plus the ln of x squared minus 1 to the 4th. Ooh, that's kind of nice right there. Minus ln of, and I'm going to write this to the 1/2. That's square root of x plus 6 is x plus 6 to the 1/2. All I did here is use the fact that ln of, and all of this is together, something times something is the addition of two ln's of those argument pieces. And then divided by that is subtraction. Not bad. Let's keep going. All right, so now we're going to keep expanding. Expand as much as you can. ln of x is chilling, but that 4 can come right out front. That's going to be plus 4 ln of x squared minus 1. The 1/2 is going to come out front, minus 1/2 ln of x plus 6. By the way, I have no idea what my accents are. I'm terrible at accents. I just like doing them. Whatever comes into my head. All right, so we're going to take the derivative of y now, because we're as expanded as we can get. X squared minus 1 cannot be expanded. Right? You cannot expand a log of something subtracted or added. Same thing here. So we're ready to derive dy dx. It's going to be very, very nice. The derivative of ln of this is 1 over stuff. D stuff is just times 1. Plus 4 is just straight up chilling. Times 1 over that stuff. 1 over garbage. Times the derivative of that garbage, which is 2x. So 1 over stuff, d stuff. Minus 1/2 is chilling out. Apparently we're slanting down here. Sorry. I'll rectify that. Times 1 over that. 1 over x plus 6 times the derivative of that. It's just 1. So I'm not going to put that down. All right, let's join this up. Let's clean it up a little bit. We get 1 over x plus 4 over x squared minus 1. The 2. Ooh, I missed the 2 there. Sorry. 4 times 2x. My word. So that's going to be 4 times 2x. I was going to write it on separately, but let's combine it right here. 4 times the 2x could be 8x. And then minus, well, we're just going to have 1 over 2 times x plus 6. That 2 comes from this right here. I leave it in factored form. If your teacher wants you to combine everything as one fraction, be my guest. If you're doing this on the AB or BC exam, that's your answer if that's all you're being asked for, is the derivative. That's it. That's all there is to it. So remember, always, please use your logarithm rules before differentiating. It makes life so much easier. All right, you know what else makes life easier? Watching some more of these videos. Got another one coming up in a little bit on something wicked cool. See you there. Peace.